Welcome to quarter 4 of Reflection VDO, and this is Mimi from grade 10G. This quarter we've learned a lot of new things in high school math 3 classes. We've completed 16 tasks, 6 big projects, and 6 standards in total. This presentation, I'll begin with standard CCSS HSF LE4. It is mainly about logarithm or the inverse of exponential function. What I've learned includes the changing of any number in the base of logarithm or exponents to 10, properties, rules, and proofs of logarithm, and lastly, the determination of domain and range of a log or exponential function. These are the proofs to show how we'll understand the lessons, which include the properties of log, changing the base to 10, and domain and range rule. This may surprisingly be applied in chemist field. For example, pure water contains hydrogen ion concentration of 1 times 10 powered by negative 7 moles. To calculate the pH of the water, we may use logarithm rules, which gives the answer as pH 7. Coming up next is the inverse function standard CCSS HSFB of 1. For a function to have an inverse, the x-coordinate is supposed to give only one y value. From the lessons, I've learned about rules, and one way to create an inverse is to reflect the function across x equal to y line symmetrically. Some skills I've learned are building function and rearranging them to be able to find a certain value. This is an example of rearrangement of function, which in this case is a conversion of exponential function to logarithm. Not only I learned them, but I also applied them to real-life situation. For example, you bought a house at a price of $200,000. The price increased at a rate of 5.7%. How many years would it take for the house to reach $1 million? By doing the process as shown below, you will be able to solve the question, which answer is 29 years. Thirdly, we got CCSS HSF BFD-4, which is similar to the previous standard. According to given task, I now can solve an inverse of a function and determine whether or not the function has inverse. Restrict the domain so that the graph will have an inverse, and I can also find an inverse by looking at graphs or tables. These are some of my work showing the solving and determining of inverse functions, domain restriction, and solving inverse with graphs and tables. An example of application is to solve a physics problem. For instance, a physician predicted that the velocity would be the function of time with rule v equals to 32t. At what time would the velocity reach 48 meters per second? Then the answer would be 1.5 seconds. In Big Project 4 CCSS HSFT of 1-2, I've used my knowledge on circle measurements to solve it. I've learned how to determine central angles, major and minor arcs, radius and angles, and also circular theorems and Pythagorean theorem. These are some circular theorems and Pythagorean theorems and formulas that I use in the lesson. Assume that you have an exponential graph showing a growth of bacteria E. coli. You want to know the growth rate at a time t. In order to solve this, you may use the rise and run function. Next in the list is standard CCSS HSFT F5, which is about revolutions of circles. I learned about the relationship between velocity, radius, circumference, and distance. I also learned about the radians and compared them to the value of angle degree in revolutions, plus the periodic function and how it is relevant to the revolutions of circle. It may be useful when you're on a Ferris wheel. You may use cosine and sine to determine horizontal position and vertical position respectively. Last but not least, we got standard CCSS HSG SRT 9-11, which is about trigonometry in general. The trigonometry is further related to law of cosine and law of sine. If you are working with a triangular-shaped object, you may find this useful. Suppose you have a 2D blueprint of a roof and you want to find its area. You may use the law of sine to first find the height before solving the area like shown in the slides. And this concludes my reflection video for quarter 4. Thank you for watching and listening.
created using Powtoon.